Alright, so we're talking about simulations here in chapter 11, and what we're doing is we're simulating some random event happening. Alright, so we can do this a few ways. I'm going to show you right now how you can do it on your calculator. You can simulate some events happening. But we can also do it using random number tables, which we're going to wind up having to do for the AP test. Alright, so a simulation is we're trying to simulate the outcome of some random event where we know the probability of that event happening, and we know that each occurrence of that event is independent. Okay, so for instance, flipping a coin. Each time we flip a coin, we know the probability of getting a head is 50-50 or 50%, and each time we flip the coin, it's an independent event. Okay, rolling a dice. Okay, that's that would be an independent event where we know the probability of getting any side of the dice is 1/6, and each time we roll the dice, it's independent. Okay, so if you go to the apps in your calculator and you go down to probability, we'll just go through a few scenarios here. Probability simulation right there, and you push that and then you push enter again. Alright, so let's say that we want to toss coins, right? And I'm going to go to set, and we're going to toss 3 coins, and we want to figure out on average how many times it's going to take us to get all heads or all tails. Okay, so all 3 coins had to be the same. Okay, so we're going to toss the coin. There we go. So we got tails, heads, tails. So nope. Keep going. Nope. Oh, it's heads, heads, tails, heads, tails, tails. Almost. There it is. Okay. So that one, that took us, like, let's say I think it was 5 times. Okay. And then we would start the simulation over again. So we would clear it out, and then we would say, okay, let's do it again. And we would continue doing that, and we would do that, I don't know, 1,000 times. And we would see on average how many times it takes us for flipping 3 coins to get them to be all heads or all tails. Okay? Another one that we could do is we can roll a dice. Let's say we're playing a game. We're going to set the game so we throw 2 dice. Okay? Let me try that again. And what we're going to do is we have to get doubles. So we got to roll 2 1s, 2 2s, 2 3s, 2 4s, 2 5s, 2 6s, or 2 7s. And when we get doubles, we win the game. So we lost. Now what the graph is totaling is it's totaling the total. That's a 7, so the 7 came up once. We need doubles. Nope. Nope. There we go. So we won. So it took us 4 rolls to win. Okay. And again, we would do this 1,000 times, and we would add up on average how many times it took us to win the game. Okay. Let's see if there's one more we can do in here. Alright, let's see, we're drawing a card. Alright, we'll go down to draw a card, and we're going to set the deck so that we're going to do it with replacement. Yep. So we're going to draw 1 card at a time, and we want to know on average how many times it will take us to get an ace. So let's keep going. Let's see. That's 2. Alright, we won on our second draw, so we got a 2 and an ace. Right, and then again we would continue to do this simulation using the deck of cards, that program that we have on our calculator. So those are a few events we could do. Okay, and then the last one we could simulate, let's say I'm going to go to random numbers, and we have I'm going to set this, I wanted to throw 1 number at a time, and the range is going to be 0 through 09. Alright, and repeat Yes, you can repeat. Okay. Alright, so what we're going to do is we're going to simulate somebody who's a 70% free throw shooter. So if we have the numbers 0 through 9, that means that we have 10 numbers. And that means 7 of those numbers represent a made shot and 3 of them represent a missed shot. So I'm going to make 0 through 6 represent a made shot, and 6, 7, 8, and 9 will represent a missed shot. So I'm going to see how many times this person shoots until they miss on average. So they made it. Made it again. They missed. Okay, so on this simulation it took them 3 times to miss the shot. Okay, so those are just some situations that we were simulating, and then I'm going to go into how we set up a simulation and how we would do it for our AP exam, because what they're going to be looking for is our methodology, and I'll explain that as we go on in our notes. Alright, so as we start chapter 11, what does random mean? Well, randomness is not chaos. People think of random as just a total chaotic event. Well, that's not what randomness is. Like you step out and you got struck by lightning. That's not randomness. Okay? Randomness is basically where you know what could happen, but not what will happen. Okay, so if I flip a coin, I know what can happen, I just don't know what will happen. If I roll a dice, I know what can happen, I just don't know what will happen. So that's not chaos. It's not like people talk about, well, they got caught in the rain, that's a random. No, that's not what we're talking about here. Okay, so the definition of random is an event that is random if we know what can happen, but not which particular outcome will happen. Okay, so that's what randomness is. Okay. So a simulation, what a simulation does is it models a random event. And how it does is it's using random numbers to specify event outcomes with relative frequencies. It's raining outside right now. That correspond to the true world relative frequencies we are trying to model. So for instance, if I'm flipping a coin, okay, I can use all 2-digit numbers. Well, all 2-digit numbers go from 00 to 99. So that's 100 numbers. Well, 50 of those numbers have to represent heads and 50 of them have to represent tails. Well, how can we make that happen? Well, we could say, well, all the even numbers are heads, all the odd numbers are tails. Or we could say the numbers 00 to 49 are heads, and the numbers 50 to 99 represent tails, as long as the relative frequency is 50-50. Okay, so 50 of those numbers have to represent heads, and 50 of them have to represent tails. Okay, that's what the relative frequency means. Alright, so what we're going to look at now is how we set up a simulation, because we're going to have to do that for the AP exam. So they don't give you a calculator and you got to do it in a very specific way. So there's basically 7 steps. The first one is to identify the component that's to be repeated. Now the component is what we're simulating. So if we're rolling a dice, then the component is one roll of the dice. If we're choosing tickets for a raffle, then the component represents one raffle ticket. Okay? So it's whatever we're simulating. Next thing, it will be how we're going to model the outcomes. In other words, when we do these, we have to assign the numbers. So in this case, we have something with a 20% success rate. Now, whenever we have an outcome that has some percentage of success that's divisible by 10, we could use single-digit numbers. If it's not divisible by 10, then we have to use double-digit numbers. So in this case, 20%, that's divisible by 10, so I could use the numbers 0 through 9, where 0 and 1 equals success, and 2 through 9 equal failure. So So 2 out of 10 numbers are success, 8 out of 10 numbers are failure. Or I could use double-digit numbers. 0, 0 through 99. 0, 0 through 19 equals success, that's 20 numbers. And 20 through 99 equals failure, that's 80 numbers. Okay, so 20 out of 100, okay, represents success, 80 out of 100 equal failure. Now, if the probability of success is 45%, now this is not divisible by 10, so we got to use double-digit numbers. So we're going to use 0, 0 through 99, where 0, 0 through 44 equals success, and 45 through 99 equals failure. Okay. Now, if we're rolling a dice, we're going to use single-digit numbers. However, we're only going to use the numbers 1 through 6. Okay? And then we're going to ignore 0, 7, 8, and 9. Why? Because you can't get a 0, 7, 8, or 9 on a dice. So we would only accept it if it comes if we draw a single digit number and we have the number 0 through 9, then we would not pay attention to any numbers that were not 1 through 6, because the outcomes of a dice can't be any other number, assuming it's a 6-sided dice. Same thing with this raffle ticket problem, right? We would use 3-digit numbers, okay, from 000 to 999, and then 001 through 600 would equal success in some way, and we would ignore 000 and 601 through 999, because those aren't any kind of raffle tickets that are part of our outcomes. Okay, so in some cases you have to ignore some of the numbers. Okay. Now the next thing we got to do is explain how we will manage each trial. You must specify the end of the trial. So if we are simulating someone taking 10 free throws, then the trial is 10 free throws. If we are simulating someone shooting until they make 5 free throws, then the trial is over when we have made 5 free throws. Okay. If we are simulating a raffle with 3 prizes, then the trial is over when we have given away 3 prizes. Okay. Next, we must define what the response variable is. So, very simple. If you're doing something out of a fixed number, suppose we say, what is the proportion of shots that a person will make out of 10 free throws? When it's a fixed number of trials, then it's usually going to be a proportion or a percentage. If we are simulating how many free throws it takes to make 5 free throws, then the response variable is usually going to be an average or a mean. Okay. Run several trials. Okay, these are the results, and I'll demonstrate how to do this in a minute. This will all make sense. Then we have to analyze the response variable. If it is a proportion, then the response variable is stated in percentages. If it is a number, okay, then the response variable is stated as a mean. Okay. And lastly, state your conclusion in the context of the problem. Okay, so you must talk about the component, what it is you're simulating. The outcomes, assign the numbers. 3. What does a trial consist of? Okay, well we're gonna select random 2-digit numbers until the person makes 5 free throws. Then the trial ends. Or we're gonna select 10 random 2-digit numbers and figure out how many free throws the person made out of 10. Then the trial is over. Okay. Then you're gonna do your response variable. You're gonna identify that. The results. You're gonna show those. Then you got to use your statistics. Okay, and that's going to be either a percentage or a mean, and lastly is your conclusion. Those are the 7 steps to doing a simulation on your AP for an AP test. All right, so what we're going to be doing in this chapter is for the simulations that we're going to be setting up is we're going to be using a random number table, which I've shown you on here. And basically we're going to use this to simulate almost anything we want. For instance, if we wanted to simulate the tossing of a coin, we could say, all right, we're going to make 1-digit numbers, and we're going to make even numbers heads and odd numbers tails. So in this case, 0 is even, so that's heads, that's tails, heads, 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 and so forth. Okay, so we have heads, tails, heads, heads, heads. All right. We can make 2-digit numbers. We could say, okay, we're going to simulate an event that's 75% likely to happen. Okay, so we're going to do 2-digit numbers, and we're going to use the numbers 00 through 99, and we'll say 00 to 74 is success, and 75 to 99 is failure. So in this case, 29 would be success, 47 would be success, 53 would be success, 56 would be success. All these would be success. It doesn't look like we get any failures here. Let's see. Nope. Okay, so everything was successful so far. Okay. We could simulate rolling a dice. Okay, let's say that we need to get a 2 to win a game. Well, how many times would we roll a dice to get a 2? So we would start here. So let's say that, okay, well, we won. Okay, so it only took 1 roll. So that was a success. Now 6 is a failure, and then a 2 is a success. A 7 we would ignore. A 1 is a failure. A 4 is a success. Failure. 5 is failure, success. So we won the game 3 times. We won it there, we won it there. It took 1, it took 2, and then it took 1, 2, 3, 4 times. Okay? So we're going to look at different ways of using this random number table to do all of our simulations, but that's basically how we're going to be doing them for our AP class. Now in real life you would do them using technology, okay, but as I'll explain to you in the next part as we go into the notes, the AP test is really concerned about your methodology and how you set up your simulation, and not so much what the results of your simulation are. Okay. Alright, so in case 1 here, suppose a basketball player has an 80% free throw success rate. Set up a simulation to model how many free throws a player will make in a row before missing. Conduct 3 trials. Now this is how they generally do it on the AP exam. Notice down here you have what's called a random number table, and that's basically where your results are going to be shown. So I've kind of set this up for you. The component, what each number is going to represent, is 1 free throw. Okay. So the outcomes, we have to assign the numbers. Well, this is divisible by 10, so I could go 0 through 7 equals a successful free throw. And then 8 and 9 equals a failed free throw. That's one way of doing it. That's with single digit numbers. Or I could do double digit numbers. 00 through 69 equals a successful free throw, and then 70 through 99 equals a failed free throw. Okay? Either one is acceptable as long as you're, again, as long as these right here are the same as this this percentage here. These relative frequencies, right, are the same as this. You can do it either way. I could do a 3-digit numbers. I could do 000 through 699, and well, we don't have to do that. So, yeah, but either way is successful. Either way is acceptable. The trial now. So we're gonna set up a trial to figure out how many times this person is going to shoot before they miss. Okay, so in this case, we're going to select. I'm going to use 2-digit numbers. Okay, random 2-digit numbers until we pull a failed free throw. And that would be 70 through 99. Then the trial ends. So that's it. The trial's over once we pull the failed free throw. Okay. Now in this case, they didn't give us a fixed number of outcomes to simulate. So the response variable here is going to be the average number of free throws shot before missing. Okay, so it's going to be an average. Alright, so here's our results, and here's how we're going to do it on the AP exam. The first number is a 10. Well, a 10 is a success. 60 is a success. 15 is a success. 01 is a success. 10 is a success. 15 is a success. 36 is a success. 02, 01, 18, 16, 47, and this is a failure. Okay. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It took 13 that time. Let's see how many they want. 3 trials. Okay. So we had success, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So it took 13 shots for us to miss. Now you could at this point draw a heavy line right here and do the second trial on the same line, and that would be acceptable. I like to do my trials on different lines, so I'm going to do my next one down here. So 22 is a success, 36 is a success, 84 is a failure. So this one went success, success, failure. And then my third trial I'm going to do down here. 24 is a success, 13 is a success, 04 is a success, 83 is a failure. So success, 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 failure. Okay, so what did I have? I had 13, and then I had 3, and then I had 4. So I came up to 20, and if I divide 20 by 3, I get 6.67. Now you may be saying, well, you can't shoot 6.67 free throws. You're right. It's an average. Okay, this is not every time the person walks up the line. This is an average. And by the way, we only did 3 trials. We would do this 1,000 times to get close to the actual number. Okay, so the conclusion, the way we always do this is we always put according to our simulation, because what we're saying is this is how we got our results. So according to our simulation, it takes an average of approximately 6.67 free throws for an 80% free throw shooter to miss once. Okay. Now, if I don't put this, and I just put it takes an average of approximately 6.67 free throws, well, it may not. Okay, our simulation is an approximation. So we're saying, listen, we did a simulation, and this is what we're approximating right here. So that's why we want to put that statement in the beginning of our conclusion. Okay, so that's how you would do a simulation on the AP exam in good form. Okay, you would include all of those steps right there to do it properly and to do exactly what they're looking for on the exam. All right, so in case 3 here, we have a raffle is run at a local event. 300 tickets are sold for $5 a piece, and 5 prizes are drawn. Suppose that one person purchases 25 tickets. Set up a simulation to estimate the percentage of time the person who bought 25 tickets will win a prize. Okay, conduct 5 trials. Now, the issue here whenever you're dealing with a raffle is one of replacement. So you may be tempted to say, oh, let's see, 25 out of 300 is like 8.3%. So if I could simulate 8.3%, then I would be okay. But in reality, wouldn't, because we have to be careful that we don't draw the same ticket twice. So our component here is going to be 1 raffle ticket. Okay. Our outcomes, we're going to use the numbers. I'm just going to assume that they are, we're going to use the numbers 001 to 025 equals a winning ticket. Just going to assume that this person has those 25 numbers. And then 26 to 300 will equal a losing ticket. So, how are we going to do this? We're going to draw random we're going to draw 5 random 3-digit numbers. We're going to ignore the numbers 000 and 301 to 999 because those, we can't have those in our raffle because we only have 300 tickets. Now you might be asking, do I have to use 001 to 300? No, you don't. You can use the numbers 500 to 799. Okay, or 501 to 800. I mean, whatever you want to use, as long as you have 300 numbers. Okay, but obviously there's 700 numbers you're not going to use. Okay, so we're going to ignore 000, 301 to 999, and all repeats. Okay. And then the trial ends. The response variable is we're looking for the percentage of time now. So they told us that right there, percentage of time. So our response variable is the percent of time the person wins. Person with 25 tickets wins the prize. Okay. Okay, so 289, that's a failure. 186 is a failure. 857 we wouldn't look at. 888, ignore it. 231, okay, that's a failure. 332 we would ignore. 767 we would ignore. 099, that's a failure. 779, ignore it. 936, ignore it. 568, ignore it. 650, ignore it. 859, ignore it. 901. Last one is 063. 063 is a failure. So in this case, we had our results. Let's see, we had 289. Actually, I'm just going to put them down as failure, 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 failure. Okay. The next trial, 635, ignore it. 534, ignore it. 096 is a failure. 148 is a failure. 235 is a failure. 034 is a failure, and 274 is a failure. So in our first two trials, we had all failures. 094 is a failure. 299, failure. 896, ignore. 952, ignore. 636, ignore. 927, ignore. 378, ignore. 897, ignore. 433, ignore. 488, ignore. 363, ignore. 201's a failure. 761, ignore it. 730, 15 is a success. Okay, so in this case, and then 082 would be a failure. So this person went failure, 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 success, failure. So they won once. Okay. 103, failure. 656, ignore it. 112 is a failure. 987, 529, 856, 894, 823, 752. Ignore all those. 267 is a failure. 676, 899, 339, 401, 511, 263 is a failure. We're going to ignore all those other numbers before it. 588, ignore it. 510, ignore it. 420, ignore it. 285 is a failure. So failure, 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 failure. Lost. And the last one is 071 is a failure. 199 is a failure. 733, ignore it. 671, ignore it. 048 is a failure. 081 is a failure. 787 is a failure. 723, I'm sorry. 787 is ignore. 723, ignore. 313, ignore. 916, ignore. 475, ignore. 648, ignore. 105 is a failure. 1, 2, 3, 4, 5. Okay. So this person on five of our trials won once. So that's 1 out of 5, and that's 20%. Okay. They only had to win once. Okay. So conclusion is, according to our simulation, we would expect someone who has 25 raffle tickets out of 300 to win approximately 20% of the time. On the AP test, you probably would want to put your results, not necessarily like that. I would probably list them. So in this one, I would put on my result line 289, 186, 231, 099, and 063, and then I would do the same thing down here. 096, 148, 235, 034, 274. I would list those numbers next to here. All right, just so that you're clear with what your results are. Okay. Alright, so you're playing a board game. 2 dice are rolled simultaneously. When you roll the dice, you add the results to get a sum. You need a 5 to win the game. Conduct a simulation to predict the average number of rolls it will take to win the game. Well, that's nice. They told us what our response variable is, so we already know that. The component is going to be 1 roll of the dice. The outcomes we can basically have 1 through 6. Okay. Actually, the outcomes you can have on each dice are 1 through 6, and 1 through 6. So really, the outcomes we can have is we can have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. We roll 2 dice. Okay. The trial is we're going to select 2 random 1-digit numbers. Ignoring 0 and 7 through 9, because you can't have a 0 or a 7 through 9 on a dice. And add up the numbers of the 2 numbers. When the sum is 5, the trial ends. Okay. Response variable is the average number of rolls to get a sum of 5. So we got a 4, an 8 we're going to ignore, and a 6. So we got a 4 and a 6. Actually, I shouldn't put that like that. That's a failure. A 6 and a 3, that's a failure. 9 we ignore, 1 and 2, failure. 4 and 5, failure. Ignore the 8s. We got 5 and 2, that's a failure. 6 and 1 is a failure. 4 and 3 is a failure. 4 and a 6 is a failure. Ignore 0, 9. 1 is acceptable, 7 is not, that's a failure. 1 and 2 are a failure. 3 ignore 0, 3 and 1 is a failure. 6, 9, 0, 6 and 2 is a failure. 2, ignore 9, ignore 0, 2 and 4 is a failure. Ignore 7, 3 and 4 is a failure. Let's see. 5 and 1 is a failure. Ignore the 9, 3 and 2 is a success. Okay, so let's see, what do we get? We got a 4 and a 6, 6 and a 3, a 1 and a 2, 4 and a 5, 5 and a 2, a 6 and a 1, a 4 and a 3, a 4 and a 6. We got a 1 and a 2 again, 3 and a 1, 6 and a 2, 2 and a 4, and then a 3 and a 4, and then a 5 and a 1, and a 3 and a 2. No good. Wow. Okay, so that one was our first success. Then we go down to the next one, 5 and 4. That's a failure. 1 and 6 is a failure. 4 and 5 is a failure. Cross out the 8 and the 9. 4 and 2, let's see. 4 and 5. 4 and 2. 0, 0, cross that out. 4 and 2 again. 1 and 4. Alright, we got a 1 and a 4. So that's a success. The next line, 3 and 2. Okay, so 3 and 2, that only took 1 time. The next line, 2 and 3. Alright, that's wonderful. That only took 1. And then we cross out 0. 2 and 4 is a failure. 3 and 3 is a failure. So 0, let's see, 2 and 3, 6 and 2 is a failure. 2 and 3. So we had 2 and 4. We had 3 and 3, 6 and 2, and then we had 2 and 3. Alright, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The first one took 15. The next one, 2, 3, 4, 5, 6. 1, 1, and 1, 2, 3, 4. Okay, so that's 21, 22, 23, and then 27 divided by 5. And that's going to be, I believe, 5.4. So our conclusion is, according to our simulation, it will take an average of approximately 5.4 rolls to get a 5 to win the game. You know, notice I keep using this phrase. According to our simulation, I keep saying approximately. Okay, if you just keep something in mind, if you were to do this and we were to do this on a calculator, all right, we were to pull up our app here, we could very easily do this. Let me pull up my probability app here. Yeah, if I was to do this and then roll a dice, so we're going to roll 2 dice. You know, again, we would do this like, we would do this, look at that, we got a 5 on the first roll, so we won on the first one. I mean, but my point is, we would do this like 1,000 times. So when I'm saying something here like according to our simulations, by the way, those are not gunshots, those are people shooting off fireworks. I'm basically saying, listen, we only did this 5 times, so this is an approximation. I don't know how accurate this answer is going to be. But again, when you're doing this on the AP test, they're not concerned with this conclusion, as long as you word it correctly. If you put down something like it will take an average of 5.4 rolls, then you're going to get docked for it, because this is an approximation. But they are much more concerned with your methodology than the answer that you wind up getting.